the last video for polynomial functions and their graphs, we used zeros to determine what the graph of a polynomial would look like. Now, I'm going to use the zeros of a polynomial in order to determine what a graph of a function, or what the equation of the function is in factored form. Now, one of the things we talked about was this multiplicity of 2 in the last video. It was also known as a double root. That was the one where the graph, instead of passing through the x-axis, it bounced off. So I want you to graph this polynomial on your graphing calculator. When you do, you get something that looks similar to this. Let's say it looks like, and then it kind of goes off your screen, and then you see this. So this is basically what you see on your screen. Well, you'll notice the graph is hitting the x-axis at -1, at 0, and again at 3. If you know the zeros, you can write the polynomial in factored form as x plus 1, x, or x minus 0 if you want, but we don't usually do that, and x minus 3. All polynomials can be written in the form x minus a, x minus b, x minus c, and so on. So whatever the 0 is, when you plug it in, it's either going to say x minus a number or x plus a number. If the 0 is negative, it's going to change it to a positive. That's why one of the factors is x plus 1 and not x minus 1. Now, what I want you to notice is that here, where the graph at that 0, it doesn't pass through, it bounces off, or it looks quadratic. Because it looks quadratic there, we say that that 0 has a multiplicity of 2. So in factored form, the polynomial looks like this. Now there's one other thing we're going to do, because this is not exactly how we would write it. First of all, if 0 is one of the zeros, then you're going to write its factor at the very beginning, and then everything else can go after that, and it doesn't matter the order. There's one other thing that I want to point out, which was that the leading coefficient was a 3. Whatever the leading coefficient of a polynomial is, when you're done factoring it, it just gets written in front of the factored form. So the factored form of 3x to the 4th minus 6x to the 3rd minus 9x squared is 3x squared, x plus 1, x minus 3. And all we did was use the zeros from the graph to help us write it in factored form. Is there an algebraic way of doing this? Absolutely. But I think this is the most straightforward. For this polynomial that we're going to write in factored form, I'm going to start by showing you the algebraic way of doing it, and then we're going to talk about how the graphing calculator can help us write this in factored form. Whenever you have a polynomial that has 4 terms, in order to factor it, we can use this process called factor by grouping, where you group the first 2 terms and the last 2 terms together. Then from each group, you factor out the greatest common factor. Once you're done, you'll notice that these 2 factor forms have the same factor of x plus 3. When I take it away, I'm left with x squared minus 9. The last thing that I want you to notice is that x squared minus 9 is one of those difference of 2 squares. And when you have the difference of 2 squares, it factors into this. And x squared minus 9 factors into x plus 3, x minus 3. So this is kind of interesting. When I'm done factoring, I have 2 of these x plus 3's, and I have an x minus 3. And that's the factored form. Let's go back and look at the graph of this. When you graph this on the calculator, you see something that looks like this. And you don't see everything on your screen, but you can tell that it hits the x-axis at -3, and the other place that it hits is at +3. Well, over here is where the graph bounces off, or has a quadratic form. So the factor is x plus 3, and it has that multiplicity of 2. Since this one passes through, it has that multiplicity of 1, and its factor is x minus 3. So I could have done the same thing on the calculator and gotten the same factored form without doing all the work factoring. Let's talk a little bit more about these multiplicities and what the graph is going to look like. Because this factor has a multiplicity of 2, that means when the 0 is 1, the graph shape is going to be quadratic. It's going to bounce off the graph. Whenever the multiplicity is 1, that means that the graph has a more linear shape, or the graph passes through the x-axis. And that's going to happen at x is 2. At x is 5, the cubic shape is going to make the graph look something like this. So there's going to be a straight part, a cubic part, and a quadratic part, whether it goes up or down. Well, how do I know which one it is? Well, you can do that using a little line chart. No, I should have. Yeah, let's go back because it's 1, 2, and 5, isn't it? All right. Let's start at 0. 1, 2, 3, 4, 5. There we go. So when x is 0, oops, let's find out what the graph is going to look like. The graph, let's see, it's going to be 0 minus 1 squared, 0 minus 2, 0 minus 5 to the third. So positive, negative, negative is going to give me a positive. So the graph is going to be above the x-axis. And guess what? I already know, because it's a double root or a multiplicity of 2 at 1, I know that between 1 and 2 it's also going to be positive before it goes negative and probably then goes positive again. So the graph is going to look like this. Bounce through, and then over here it's going to kind of have a weird little cubic shape. And there's my double root at 1, no double root at 2, and a cubic root at 3, which makes the graph have kind of a cubic shape. If you graph that on your calculator, it'll have a similar shape to it. In Chapter 2, we talked about finding maximums and minimums on graphs. And maximums and minimums are called extrema. Anytime a graph has a high or a low point, we call it extrema. So in order to determine the number and the location of extrema, the number is pretty easy. The number of turning points in a graph is going to tell you how many points of extrema there are. So if you graph x cubed minus x in your calculator, and you may also have to zoom in to really get a good idea of what it looks like, you'll see a graph that looks like this. And it hits the x-axis at -1 and +1. Again, I had to zoom in to see that. This has 2 extrema. It has a maximum here, and if I use the maximum function on my calculator to determine where it's at, I find out that it's at -0.58, 0.38. And it has a minimum here, which I will again use the minimum function on my calculator to find. And I'm going to find out that it's at +0.58, -3.8. Oops, 0.38. Sorry about that. So the number of extrema are the number of turning points on a graph. Some graphs have several of them. Some only have one. Linear graphs have none. Once you know the number of extrema, you can find them using the maximum and minimum functions on your calculator. Now let's graph x to the 4th minus 8x to the 3rd plus 22x squared minus 24x plus 5. When you graph that on your calculator, you get something that looks like this. This particular polynomial has 1, 2, 3 extrema. There are 3 locations where the graph changes directions. So, working from left to right, The first one is at a minimum. How do I know? Because it's a low point on the graph. And that minimum is at approximately 1, negative 4. The second extrema from left to right is at a maximum because it's at a high point. That maximum is at approximately 2, negative 3. I'm just using the min and max functions on my calculator. And then the third one is also a minimum. And it is at approximately 3, negative 4. The last problem we're going to look at is a family of polynomials of the form x to the fourth minus kx squared plus 3. And we're going to change the value of k and see what happens to the graph as we do this. So I'm going to start by putting in 0 for k, which means that I'm graphing x to the fourth plus 3. The shape of that graph just looks like a parabola. But now I'm going to go and I'm going to change k to be 1. When I make this x to the fourth minus x squared plus 3, now when I go and graph this, it kind of looks more like blocky down there at 3. Now I'm going to go change this again. So now I'm going to graph x to the fourth minus 2x squared plus 3. I don't even need to change the whole thing in my calculator. You can insert a 2 and then regraph it. And then you'll start to see that when I make x is 2, or k is 2, sorry, all of a sudden it has that W shape to it. Now I'm going to go change that again, and I'm going to make that a 3 and see what happens to the graph. What you're noticing is that as you change the value of k, that W shape becomes more pronounced. So I'm going to do this one more time. When k is 4, x to the fourth minus 4x squared plus 3, it's going to make that W pretty pronounced. It's going to look like, oops, sorry about that. It's going to look like this. But I want you to notice that no matter what we did, in the center of the graph, the very center of the graph, it always went through 3 on the y-axis. But changing the value of k made that a more and more pronounced W shape, which is traditionally what we see with polynomials that are fourth degree.